IBGP neighbor relationships occur when we have two routers running in the same autonomous system, 5 and 7 for instance. 6 and 8, those would be IBGP peers. So we have external BGP and internal BGP. I want you to understand that when we're setting up internal BGP, both neighbors have to be pointing to one another. That's the same as eBGP. You have to have explicit configured neighbor statements. You point to them, they point to you. The neighbors must be able to reach one another. That's no surprise. But a true BGP implementer would need to teach you more than just this. And let's do that. When we are speaking about BGP and the IBGP configuration, IBGP neighbors must be in a full mesh of peers. Let's get that to a better spot in the page. That could easily be the first bullet point that we discuss, and most important. Now we have a full mesh between our 5 and 7, as it looks like there's only two routers, and 6 and 8. But what if R1 needed to run BGP? If R1 needs to run BGP, then we've got a real problem on our hands if we don't understand the full mesh of peers need. And that is caused by the IBGP split horizon rule. Now, think about split horizon. Where did you see that first? You probably first saw it in a basic discussion, in an early discussion of routing. And you would have seen it for distance vector routing discussions. Now, we're dealing with a path vector routing protocol, but there is a split horizon rule within BGP. It's different. It is not about interfaces and making sure that routes go out a different interface. It is more about making sure that routes don't get re-advertised into the same autonomous system. So what happens is this. Routes learned via IBGP will not be reshared with other IBGP neighbors. Let's make sure we understand this. The IBGP rule, says routes learned via IBGP will not be reshared with other IBGP neighbors. Okay, let us see how this would work. Let us say that we had not a full mesh, but kind of like what a BGP novice would think. And it's okay to be a BGP novice. It's okay to be a BGP novice, but I want you to understand what would happen here. That looks like a lot of BGP neighbors, IBGP in flavor. If R4 receives routes, let's say that our routes are of, let's say, the light blue color. So we get routes going from R7, R5, learned by R4. They're going to go from R4 to 2 and 3. Those routes will not be reshared. They will not be reshared from R3 to R1. So how are you going to deal with this? You are going to set up a full mesh of neighbors. And I don't want it to be that color. You're going to set up a full mesh of neighbors. R4 is going to peer with R1. R1 will peer with R4. And hey, R2 and 3, those two routers will peer. And it looks like a big old mess, right? Well, it is but that's just how it has to work. Now those routes can go from R2 and R3 over to R1. That is such a critical element to BGP neighbor relationships and the configuration of them. So, do these routers need to be directly connected? No, they do not. R4 and R1 are not directly connected. And therefore, we can see that IBGP behaves differently with regards to time to live. The time to live is not set to 1. And so that communication, those BGP packets can cross from R4 to 3 to 1. And it would be when we're stretching with the BGP communication that stretches specifically from R4 to R1. Master this, and you've got a lot of impactful knowledge in your arsenal for BGP implementation. I can't stress this enough. This is a very critical element to BGP.